again. And what I'm going to do here, y'all, is we're going to go through the third section for the day, y'all. So, um, guys, similar figures is the next portion that we have. The nice thing about similar figures, y'all, is that we already know how to set these problems up, believe it or not. Okay. Let me show you something, y'all. The idea in similar figures is that we have two triangles or two rectangles or something like that, and they look similar, right? One is just a little bit smaller than the other one. Okay. Now, y'all, the way we set up these problems is we use a ratio and proportion. We set up one fraction equal to another one. So look, y'all, there's a couple ways you can do it. We can say, look, the small side of the small triangle is 3, and the long side of the small triangle is 6. And I'm going to compare that to the small side on the bigger rectangle and the longer side on the bigger rectangle. Does that make sense how we set it up? Right? So we're saying, look, 3 goes to 6 like x goes to 9, right? And then how do we set this up? The same way, y'all. We're going to cross multiply. So 6 times x is a 6x. 3 times 9, y'all, is going to give me a 27. Now, y'all, these questions, I didn't make these multiple choice, but same kind of thing, right? Same kind of problems. Look, guys, I'm going to take my calculator and say, what's 27 divided by 6? And I'm coming up with 4.5. Okay. So how you set up your first ratio, guys, or your first fraction tells you how to set up the second one. Okay. Guys, I got another problem here, almost identical. Okay. So look, I'm going to compare the small side on the big rectangle, 12, okay, to the long side on the big rectangle, 18, and then I'm going to compare the short side on the smaller rectangle to the longer side on the smaller rectangle, right? Yeah, another way you can think about it like this is look like this. Look, 12 compares to what? To 4, right? So look, 12 compares to 4, like the way 18 compares to n. Does that make sense? Right? So again, it's how you set up. So, but it's basically the same kind of setup, right? Look, y'all, let's cross multiply. So 12 times n, boom, 12n. 18 times 4, I don't know. We're going to find out. 72. And then we're going to divide by the number in front of my letter. In this case, it's n. So 72 divided by 12, y'all, nice and neat. Pretty number. Oops, sorry. We get 6. Okay. All right. Yo, let me scroll down a little bit further. Okay. So I have another problem here, y'all. It says the tallest tree standing today is a redwood located in the Humboldt Redwoods State Park near Ukiah, California. Okay, guys, we want to find how tall that tree is. Okay. So, y'all, if you look, we have our tree and we're looking for the height. We're looking for this distance right here. They're calling it X. And that tree, y'all, has a shadow. And the shadow of that tree, y'all, is 73 feet long. Now, over here, we have a flagpole. That flagpole, y'all, is 10 feet tall, and its shadow is 2 feet long, right? So let's do this. Let's do a ratio and proportion. Look, y'all, why don't we do this? Why don't we say, look, the height of the tree, which we're calling X, we can compare it to the height of the flagpole, which is 10. And then the shadow of the tree, I'm sorry, which is 73, is going to compare to what? Over 2, right? Look, y'all, we're going to cross multiply now. 2x. 73 times 10, y'all, is going to be 730. Okay. We're going to divide both sides by the number 2. 365. So, y'all, that tree is 365 feet tall. Is that pretty tall? You know why? It's the tallest tree, right? It's the tallest tree. Good. So, guys, there you go, right? But you see how these problems are kind of the same thing as the ratio and proportion, right? Okay, Yo, let's take a look. I do have some here that are multiple choice. Okay, so let's see if we can do some comparisons here, y'all. Look what we got here. We got two triangles, and y'all, one is embedded in another. Yo, one thing I always tell my students, if that kind of throws you off compared to other problems, do this. Look, go like this, big triangle with 6, 8, and X. And then right here, put a small triangle with 3, 4, and 5. And then maybe it doesn't throw you off as much. Okay, you know what I'm saying? Okay, so look, y'all, this one is multiple choice. We're going to do the same thing, right? So look, y'all, one fraction equals another one. Y'all, the one thing that we're trying to do here, we're looking for that missing piece. Okay, why don't we do this? Why don't we say, look, X compares to what? 5? So look, y'all, X compares to 5. And then, y'all, it didn't really matter which one of these we use next. But since I'm starting off with the big triangle, this is the big one, this is the small one, right? I'm going to keep that same kind of action going on here. Why don't we say 8 is to 4? Right? Does that make sense? Okay, guys, we're going to cross multiply again. 4x. 5 times 8 is 40. So when we divide both sides by 4, I'm coming up with 10. Is that one of my choices? Yeah, it's choice C, right? Boom, there it is. Okay, there it is. All right. So again, y'all, if they draw something like that for you, just draw the two triangles separate. Okay. If it throws you off, draw them separately, and then you got the same idea. Okay. All right. So y'all, look at this next one here. A flag post casts a shadow of 40 feet. Okay, so we have a flagpole, y'all. Here's my flagpole. Okay. And the shadow of the flagpole is 40 feet. Okay. And then nearby, a 5-foot tree. So look, y'all, we got a tree. Okay. And that tree is 5 feet tall, but its shadow is only 4 feet. We want to know what is the height of the flagpole. So look, y'all, we're trying to find this height right here. Okay, look, let's draw a triangle. Boom, boom, right? So again, y'all, first thing I'm going to do, I'm going to say, look, I'm going to say one fraction equals another. So I'm going to say X is to 5, just like what 40 is to 4. And then again, y'all, we'll cross multiply. That's a 4x. 5 times 40, y'all, should be something like 200. So when we divide both sides by 4, coming up with 50, right? 50 feet. And if you notice, y'all, that's my choice C, right? Y'all, if you notice in this problem, they didn't draw the picture for me. So I have to draw the picture myself, okay? But we drew it. It wasn't too difficult to do. We had a flagpole. We drew its shadow. We had a tree. We drew its shadow. And then we could kind of do our comparison, okay? Okay, y'all, that was the last section. Short and sweet, right? Short and sweet. Nothing out of the ordinary here. Y'all, let me go ahead and stop recording this part of it. So I'm going to stop recording that part.